Students, this is Unit 8, Area and Solids, Lesson 8.7, Spheres. Taking a look here, don't forget the date, time, location, as well as a parent or guardian sign-off. Please do not attempt to multitask, students. Okay, so we're going to do a review problem here. I'd like you to take a shot at these two review problems on your own. We start the video with a red pen in hand, ready to correct. Pause. Alrighty, let's check. Welcome back. So this is a cylinder. Right on the volume of a cylinder is area of the base times the height. And our base here is circle. So our base is going to be pi r squared. We know that our radius is 16, so I'm going to go 16 times 16 pi. Now the height, oh look at that. I have it, that's x. Okay, so base times height, but we have to use there with an equal sign is 6144 pi units cubed. So we're going to solve for x here. I'm going to go ahead and divide by 16 squared. So I have pi times x equals 6144 divided by 16, and then divided by 16 again. Oh, it's 24. So that's going to equal 24 pi, and of course you cancel the pi's. So your height here has to be 24 units. This one, we went the volume here, shade base equations, circle plug said. We shade our base. It is a square. So our base is basically 10 squared, which is, of course, 100. Then we have here our slant height is 13. If we go in this way, that's 5. And you want your true height, which you don't know. Pythagorean theorem. 5 squared plus unknown squared equals that 13 squared. So x is the square root of 13 squared minus 25. X is the square root of 144, and our height here should have been 12. So volume of a pyramid, base times height over 3. Our base is 100. Our height is 12 over 3. 3 goes into 12 4 times. Your final answer here should be 400. Check for units, meters cubed. Take a moment. If you got any of that wrong, write yourself a little note about what to do in the future. Warning, ladies and gentlemen, you will be doing a brain Java next class, which includes problems like this, volumes of prisms and cylinders, as well as problems like this, volumes of pyramids and cones. Watch out for an extensive brain Java next class. Today we're going to be talking about spheres. Spheres, but before I talk about spheres, there's a word I need to quickly discuss, and that is the concept of surface area versus volume. Read that question in the black. So we're going to distinguish between the concept of volume and the concept of surface area. So surface area is the area of the surface of a solid. You want to think of it as like the wrapping paper. Of a gift. It measures the outer area of a solid. So that's surface area. So if I wanted the surface area of this box, I would find the area of the top and bottom. I'd find the area left and right. And I'd find the area front and back. There'd be a total of 6 panels I'd find the area of to find the area of the wrapping paper. Volume is the amount of stuff inside, or like the gift itself. So wrapping paper, surface area, outside, volume, inside. Let's clarify dimensions once again. One dimension is just finding the single length of something. So if I were to trace this segment, and the length of that segment is 4, that is one dimension. Dimension is just length. Now, if that solid was unfolded like wrapping paper, and you were to find the area of this wrapping paper, so just kind of shade this here. Two dimensions is area. So that would be like finding the area of wrapping paper. Three dimensions is the amount of stuff on the inside of a solid. So if this were a hollow shape, like a triangular vase, if you will, and I were to fill it up with water all the way to the top, fill it up with water. Imagine that water in there, filling it up all the way to the top. That would be volume. Filling something up on the inside. So let's continue the exploration of two-dimensional area, doing a concept called nets. Nets are where you take a solid and you unfold it flat as if it were like a pattern. For those of you who've done sewing in the past, it looks like a pattern. Okay, so you basically undo the solid. For example, this is a net of this. We're going to color code it here. So we have the square base, and then we have the triangle attached to it in the back, laid flat. And then we have the triangle to the left and right of that, laid flat. And then the triangle down the front face, laid flat. So by taking and folding flat the shapes that make up a solid, that's what we call a net. Okay, so that you understand that, we're going to take the following and fold it out into a net. This is where colors come in very handy. Okay, and there's several ways to unfold it. So you don't have to do it exactly my way, but I'm going to start by color coding here. Just going to start with that bottom edge. Draw it like so. So that edge, that is 15 times 6. All right. And then I'm going to flank it, if you will. It means on either side with the 2 left, right squares. You want to take the number to bring your numbers over. So this is still 15. And then that edge right there is 13. Now I'm going to take this one top. I'm going to add it right there. Of course, that's still 15, and that edge is 6. Then I have the 2 additional yellows right here. There's a couple ways I can fold that. It really doesn't matter which way I fold it, but I'm going to connect it to the base as a couple flaps. And once again, there's more than one way to make a net. But the way you know you're correct, if you were to imagine this as a flat pattern in your hand and physically fold it back together, it would look like that solid on the left. Let me bring that number over. That edge right there is 13. So if I wanted you to find the area of this net, you would simply find the area of each of these rectangles, and you would add it up. Let's try this again. We're going to make a net of this hexagon. So I'm going to start by making my pentagonal prisms. And then attached to each one of those, we have 1, 2, 3, 4, 5 flaps, if you will. Lay that flat. And here we have these edges are 13 all the way around. And of course, that edge is 7. So each of those rectangles are 13 by 7. You're just kind of drawing out the flat version of everything. And then it doesn't matter, but I'm going to attach where you attach it, but I'm just going to attach the other pentagon to any one of the edges here. So I'm going to attach it to this edge. So that if you were to fold this together, it would create that solid again. And our apothem there is 8.9. Of course, each of these edges are 13 again. So that's a net. If you were to lay it out flat, so just that you get some practice here, I'd like you to take these 3 solids and to the best of your ability. Whoop, nope, that's not you. Try yet. That's a meat tray. So let's go ahead. Pyramids are super easy. All you do is we're going to just start by doing that base. The edges are 6 there. We're going to, and my apothem there is 4.1. And each of these sides, there's going to be 5 triangles folded downward. You watch carefully. That slant height is actually the actual height of a single triangle. Or any one of these triangles, that height is going to be 8.1. There is the net of that pyramid. Now, cylinders or cones are going to look a little bit strange because they don't exactly have flat surfaces. But for a cylinder, we're going to start with the fact that we do have a flat circle. You will pull it apart. And think of this as a label on a can. This is actually one elongated rectangle because it's like a label on a can. And then this could be folded down pretty much anywhere else. Once again, if I were to roll this and fold those 2 flaps down, you're going to end up with that cylinder. And this edge right here is where it gets tricky. So that's 22. This right here is your 20. So that squiggle edge is the exact same length as the circumference. Can you see that? So that's going to be C equals C pi. So that length is technically going to be 22, in this case, pi. When you slice open a cone, the cone again starts with that circular base, but now there's only one of them. Radius of 8. If I were to slice this edge and fold it out, it wouldn't be quite a complete circle, but it would be a shape that looks kind of like this. So it's a curved, kind of a triangle thing, but there's a curved edge there. So you'd have to roll it into a cone. And this is your slant-eyed edge, 18.8. So these are all called nets. And if I wanted to, I could find the area of any of these. And what we would be getting is the wrapping paper surface area. I'd like you to take these nets and fold them back into a solid. Do bring the numbers over. Fold these nets back into a solid. Pause the video. Okay, let's see how you did here. This first one is going to be, of course, a cone. Take this and we're going into solid, so we got it. The diameter there is 10. That's my edge. Get down into a cone. My slant height is 16.8. 16.8 is not the true height. So there's a cone. This one, this is a triangular prism. So if you were to fold this back, it would be like 11 and 11. Notice it's isosceles. That edge, 8. I'm going to drop it down into That's 11. You dot that. That's 11. That edge right there is the 8. And then we have our height, which is 14. So there's your solid. That's a triangular prism. Of course, this is a square-based pyramid. And that 24 is a slant height. And there you are, square-based pyramid. Hopefully you got close in your drawings. Okay, all that leading up to the sphere, all that leading up to a sphere. There are 3 reasons why spheres, I love spheres. 3 reasons. 1, they are easy to draw compared to something as complex as, let's say, a pyramid where you have 2 different heights, or triangular prism. Spheres are super easy to draw. In geometry, we're not going to worry about shading. In art class, you will. But in geometry, to draw yourself a sphere, you just draw yourself a circle. And then think of it like an equator. You draw solid going one direction, dotted going the back side to represent depth, and put a center, and behold, in geometry, that's going to qualify as a sphere. So they're easy to draw. There's no what's called lateral area. There's no labels. It's also really nice about a sphere, you only need one single measurement. Just one, folks, and that is the radius. Now, when you're working with the sphere, there's 2 things we're going to talk about. The surface area of a sphere, and then the volume of a sphere. The surface area of a sphere, that's like wrapping paper. 2 dimensions. So if I wanted to talk about if this right here was a basketball, and I wanted to know how much material was needed on the outside, the outer rubber material to make the basketball, that would be a surface area concept. And to find the surface area of a sphere, we put SA. It's like wrapping paper, the outer portion. All you do is it's R squared. I want you to circle that square and circle that too, please. Times pi times 4. That's it. Surface area of a sphere. That's how hard it's going to get. You square the radius times pi times 4. Notice I'm not taking a lot of time to explain where these equations come from. I'll give you a little animation of it in class, but right now we're just going to work with the equations. Now, volume, if I wanted to figure out how much air goes inside the basketball, that would be volume. Volume is a 3-dimensional concept. Back to our gift analogy, it's not the wrapping paper, it's the gift inside. To find the volume of a sphere, you're going to start with R cubed. Now circle that 3, Circle that 3. I want you to see how those relate to each other. Also times by pi, times by 4, but for volume, we're going to final step divide by 3. Once again, I'll give you a animation in class why that's the case. So that's your surface area, that's your volume. Notice they both have exactly the same base, 4 pi r, 4 pi r. Notice there's something special about the exponents and the dimensions. The exponents and dimensions, that'll help you keep track of stuff. We're going to do a couple problems together. And we'll be done. We're going to find the surface area and the volume of the sphere in exact terms and also approximate decimal form. So we're going to do both forms. Exact means pi form, approximate is decimal form. So let's start by writing our equations. For a sphere, you start with r squared for area. Volume, you start with r cubed for volume. Pi, pi. 4, 4, only addition for volume, that's over 3. So ready? Let's do surface area. Trace our radius, we're going to plug it right in there. 8 squared, pi, 4. Obviously, this is going to be 64 times 4. And we get our surface area, that'd be the area of the wrapping paper, is going to be 256 pi, check units, inches squared. Approximate sign. This is decimals are approximation. Pi form is the most accurate. So 256 times pi, I'm going to take it to the second decimal place, 804.25 inches squared. So this is exact pi form and the approximate form for the surface area. Volume, it's going to be 4 pi 8 times 8 times 8 over 3. Eight times 8 is 64, times 8 again. So 8 times 4 is 32, 8 times 6 is 48, that's 512. That takes care of all 3 8s. For those of you who are like freaking out, I didn't use a calculator. Let me just show you that's 8 cubed, 512, folks. And then we're going to times by that 4. Look, Mom, no calculator because you're smart like that. And then that's not divisible by 3, so my volume in pi form is 2048 thirds pi inches cubed. And that is perfectly fine there. That is exact radical form. Decimal form. And take that, divide by 3, times by pi, second decimal, 2144.66 inches cubed. So then you're going to have problems like this, where you have to work backwards. I want you to here is 7,238.2295 meters cubed. Find the surface area. So let's start by writing what we have so far. Volume is 7,238.2295 meters cubed. We're wanting the surface area. Let's write that equation out. 4 pi r squared. We want that. Problem is, we don't have the radius. But you ask yourself what you do have. We have the volume, so I'm going to write my equation for volume right here. 4 pi r to the third over 3 equals 7,238.2295. Our goal is to solve for the radius. So watch what I do very, very carefully. My radius squared, or cubed, excuse me, my radius cubed. I'm basically going to flip this inverse, and I'm going to times by 3, but divide by 4 pi. So I'm multiplying by the inverse. And that's going to get me r cubed. Watch what I do here on the calculator. Okay, I'm going to take 7,238.2295. I'm going to times by 3 first off. Now I'm going to divide by 4. I'm going to divide by the pi key. And you see I get 17.28. Okay, and for cube rooting, now watch very carefully. Some of you have a cube root function on your calculator. I have a cube root function on mine. That's not square root. 1728 cube root. That means what number times itself 3 times? And minus 12. Now, if you didn't know that, you would simply start working 1 through 20, and you could guess what would be, 2 times 2 times 2, 3 times 3 times 3. You just kind of keep working at it until you get that number. Okay, and if you keep going there, if you go 12 times 12 times 12, you would have found your radius. So we just found our radius, which is 12. We want to find the surface area. 4 pi r squared. It's going to be 4 pi 144. I'm basically going to do 144 times 4. Final answer, 576 pi, check for units, meters squared. This page you're going to do on your own, folks. When you are done, check your work. When you are done, check your work. Pause the video. Okay, let's restart. We're going to find the surface area and volume in exact pi form. Let me write the equation for each. This is 4 pi r squared is surface area. And then 4 pi r cubed over 3 is your volume. So this one is simply 4 pi 9 squared So it's 4 times 81. Volume is 324 pi yards squared. This one I'm going to have 4 pi 9 times 9 divided by 3. So I can see here I basically have 12 times 81. And my final answer here is going to be, that was surface area up there. Volume equals 972 pi yards cubed. Here, exact same thing, but you should have realized that your radius was 3 this time. So this is 4 pi 3 squared. And this is going to be 36 pi meters squared. And here we are with volume. Your radius again is 3, so it's 3 cubed. 3 times 3 times 3. Why don't I multiply it out? Because the key to multiplying is not multiplying. We have our 4 here over 3. And we go ahead and cancel that out. So our volume, that's 9. 4 times 9. Looky there, it ends up being exactly the same thing, but not exactly the same thing because our units are cubed. So be prepared, guys. When you see this, that is not the same thing. This is like saying I have 36 $5 bills versus 36 $20 bills. So just because you see that 36, it doesn't mean it's the same thing. Units are everything. So this down here, you had to work backwards. The surface area, that's 4 pi r squared, is, that's an equal sign, 400 pi. Your goal is to find the volume, and you need the radius for that. So we're going to solve for pi here. Divide by pi. Divide by pi. Cancel. Cancel. I have 4 r squared equals 400. And of course, divide by 4 r squared equals 100. So radius is 10. Your volume was 4 pi r cubed over 3. So 4 pi, 10 times 10 times 10 over 3. 10 times 10 is 100, times 10 again is 1,000, times 4. So our volume here in pi form is 4,000 thirds pi units, and it's going to be cm cubed. 4 pi cm cubed. Students, I highly recommend you take the time, just 2 minutes, to recap a few seconds each page. What did you learn on each page? Just a few seconds each page. By verbally recapping, it'll help you recall the information when you have brain Javas and assessments coming up your way next class. Again, just go through each page, take about 20 seconds each. What did you learn on each and every page?